Imagine looking up at the night sky and seeing a universe completely different from the one we know today. Not just slightly different, but more chaotic, more violent, and far more alive with creation. Now rewind time, not thousands, not millions, but 10 billion years into the past. At that moment, the universe was in what scientists sometimes call its cosmic noon, a period when galaxies were growing rapidly, stars were forming at incredible rates, and the foundations of everything we see today were still taking shape. But here's the question that makes this journey even more fascinating. What did that universe actually look like? Could planets already exist? Could life somewhere have already begun? And if so, could something have been watching that ancient sky? In this video, we're going to travel deep into time, exploring what the universe was like 10 billion years ago, how it evolved to that point, and what it means for the possibility of life beyond Earth. Stay with me, because by the end, you might look at the night sky in a completely different way. To understand the universe 10 billion years ago, we first need to zoom in closer to home, our own planet. Around 3.5 billion years ago, life already existed on Earth. But this was not the blue and green world we recognize today. The atmosphere had almost no oxygen. Instead, carbon dioxide levels were between 10 and 50 times higher than today, and methane concentrations were also significantly elevated. If you stood on ancient Earth, the sky might have appeared hazy and orange, similar to the thick atmosphere of Saturn's moon Titan. The sun itself was dimmer, only about 75% as bright as it is now. Life at this stage was simple, microscopic, and likely clustered around hydrothermal vents in the oceans. These organisms formed layered structures over time, which eventually became what we now call stromatolites, one of the earliest signs of life ever discovered. But even at this early stage, life was already diverse at the microbial level. This suggests that life must have originated even earlier, perhaps 3.7 billion years ago, or even more than 4 billion years ago. The exact moment remains one of the greatest mysteries in science. Now let's go further back, to the birth of the solar system around 4.6 billion years ago. It all began when gas and dust in space collapsed under gravity, possibly triggered by a nearby supernova explosion. This collapse formed the Sun, followed by gas giants like Jupiter and Saturn, and eventually rocky planets like Earth. But the early solar system was chaotic. Giant planets may have migrated inward, disrupting smaller forming planets. At some point, a massive collision between early Earth and another protoplanet likely created the Moon. This violent beginning shaped the stable system we live in today. Now we move even further back, to about 5 billion years ago. Something remarkable happened to the universe itself. Since the Big Bang, the universe had been expanding, but due to gravity, that expansion should have been slowing down, and for billions of years it did. Then suddenly, the expansion began accelerating. This acceleration is attributed to something called dark energy, a mysterious force that makes up a significant portion of the universe. Around 5 billion years ago, as matter became more spread out, dark energy began to dominate. pushing galaxies apart faster and faster. Even today, this expansion continues to accelerate. Next, we travel to around 8 billion years ago. By this time, the universe had undergone enough stellar evolution to create heavier elements like carbon, oxygen, and iron. These elements are essential for forming rocky planets. Early in the universe, only hydrogen and helium existed, too simple to form solid worlds. But as stars lived and died, especially in supernova explosions, they enriched space with heavier elements. Over time, this allowed rocky planets to form in greater numbers. However, not every region of a galaxy is suitable for complex life. If a planet is too close to the galactic center, radiation and frequent supernovae can make it unstable. Too far out, and there may not be enough heavy elements. There is a sweet spot where conditions are just right. Interestingly, studies suggest that many planetary systems capable of supporting complex life may actually be older than our own solar system. This raises an intriguing possibility that life elsewhere in the universe could be far older than life on Earth. And now, we finally arrive at 10 billion years ago. This was a time when the universe was far denser than it is today. Galaxies were still forming and growing rapidly. Star formation rates were at their peak, up to 10 times higher than what we observe in the present universe. Why was star formation so intense during this period? The answer may lie in dark matter. Dark matter, which makes up over 80% of the universe's matter, does not interact with light, but it does interact through gravity. After the Big Bang, dark matter began forming large-scale structures, like a cosmic web. Normal matter, such as gas, followed these structures, flowing along filaments into galaxies. Because these structures were still forming 10 billion years ago, gas could flow efficiently into galaxies, fueling rapid star formation. At the same time, galaxy collisions were far more common. When galaxies collide, gas is compressed, triggering even more star formation. These mergers also contribute significantly to the growth of galaxies. Our own galaxy, the Milky Way, likely experienced such a collision around this time, merging with another galaxy. The evidence of that event can still be observed today. But perhaps the most dramatic feature of this era was the growth of supermassive black holes. As galaxies merged, their central black holes could also merge, creating even larger black holes. Around these black holes, enormous disks of gas formed, emitting intense radiation. These objects, known as quasars, were some of the brightest objects in the universe. To give you an idea of their brightness, if a quasar like 3C273 were located at the center of our galaxy, it would appear as bright as the full moon in our sky. Now imagine a universe where nearly every galaxy contains such a brilliant, energetic object, and where collisions and radiation are constant. It would be a spectacular but extremely dangerous cosmic environment. So this brings us to a profound question. Could life exist in such a universe? On one hand, the intense radiation and frequent cosmic events would make survival difficult. On the other hand, the building blocks of life, water and organic molecules, already existed more than 12 billion years ago. We even know of ancient star systems, formed over 11 billion years ago, that contain rocky planets. So, while the conditions may have been harsh, the possibility of life cannot be completely ruled out. So here we are, back in the present day, looking out at a universe that has already lived through its most dramatic era. The stars we see tonight are the result of billions of years of evolution, shaped by forces that were far more intense in the past. 10 billion years ago, the universe was brighter, more chaotic, and full of creation. Galaxies were colliding, stars were forming at incredible rates, and black holes were growing rapidly. It was a time of cosmic transformation, a time that set the stage for everything we see today. And yet, one question still lingers. If the ingredients for life already existed back then, could there have been someone, somewhere, watching that ancient sky? Perhaps even now, across the vast distances of space, there are civilizations that began their journey billions of years before us, still evolving, still exploring, still looking up at the stars, just like we are. The universe is not just a story of space and time, it is a story of possibility, and maybe we are only at the very beginning of understanding it.